In this video, we are going to take a look at simplifying expressions using properties of logs. Let's look at example 1. In E, we have 10 to the 3 log no base, so that's basically a base 10 of 5. I guess one thing we can do is use our property of logs, and let's bring that 3 up as an exponent. This would be the same as 10 to the power of log of 5 to the third power. Now what I have is that because there's no base in the log, this is technically base 10, and I know that 10 to the power of and log base 10 are inverses of each other. They'll cancel out, and so what we're left with is 5 to the third power, or that'll give us 125. As we look at G, we have 10 to the power of 1 plus 2 log x. I do notice that I have a plus symbol there. One thing I remember from my exponent properties is a to the power of m plus n is the same thing as a to the power of m times a to the power of n. So if I break this up, this is the same thing as saying 10 to the first times 10 to the 2 log x. I can't do much else with 10 to the first, so I'll leave that alone. But what I do have now is that the 2 can be brought up as an exponent, so I have log of x squared technically, and because we have a base 10 again, 10 to the log 10 cancel each other out, they're inverses of each other, and what we're left with then is 10x squared. As we take a look at example 2, let's look at some properties of logs. Let's do B, log base 8 of 2 minus log base 8 of 32. Because I have the separation of logs with a subtraction symbol, I know that this property can bring those together as one whole log. I'll have log base 8 since they're both log base 8s there. And then what we have is 2 over 32. Now 2 over 32, that can be simplified. That's the same thing as 1 over 16. And I'm getting a little stuck here. I don't know what this value is, so I'm going to call it x. What I can do is my loop trick again. So what I have now is 8 to the power of x equals 1 over 16. I'm still getting a little stuck here, but I do know that 8 and 16 do have things in common. More specifically, it has a base 2 in common. 8 is the same thing as 2 to the third power, so what I have is 2 to the third to the x equals, and 18 is the same thing as 4 times 4, or that's the same thing as 2 to the fourth power, but because this is reciprocal, that's technically to the negative first power. I'm just going to simplify this out a little bit. What we have is 2 to the 3x is equal to 2 to the negative 4. And because they have the same base, what I'm saying is that 3x is equal to negative 4, or x is negative 4/3. Okay. Let's take a look at letter D. E to the log base e squared of 25. That's a little different. Well, what we do see is that we have e to the log base e squared. 25 is the same thing as 5 squared. And, I can't cancel these e and log base e squared out because, well, this is just an ordinary e, and this is a base e squared. But what I do see also is that there is an exponent of 2. What would happen if I bring that exponent of 2 down as a coefficient? We'd have e to the power of 2 log base e squared of 5. Again, using my properties of exponents, a to the power of m n is really the same as a to the power of m to the power of n. So what I'm trying to show here is that technically we have 2 times log base e squared 5. This is like mn. Okay, so what we can rewrite this as is e squared to the power of log base e squared of 5. And just like we've seen with properties of logs and exponents, they are inverses of each other. Now e squared and log base e squared can cancel out, and now we're just left with 5. Page 3. Use properties of logs to write each log in terms of a and b. Express in terms of log base b of 2, which is a, and log base b of 3, which is b. So now notice we have 72. That has, really, there's no 2, there's no 3 in there. We got to break it up. We got to figure out what 72 is made up of. Let's just do a little tree diagram to help us. 72 can be thought of as 2 and 36. 36 is 6 and 6, and that's 2 and 3, and 2 and 3. Okay, so technically we have 1, 2, 3 2's. So log base b of 72 is made up of 2 to the third power, and we multiply that by another 3 and 3. So we have two threes, so 3 squared. So I'm breaking it up so that now we actually have it in terms of log 2's and log 3's. And then using our properties of logs, we can break this up a little bit more. This is the same thing. If you're multiplying two values, this is the same thing as saying log base b of 2 cubed plus log base b of 3 squared. Another property of logs says that we can take those exponents and bring them over as coefficients of our logs. So now what we have is 3 log base b of 2 plus 2 log base b of 3. Log base b of 2, if you recall, is technically a, so that's 3a. And log base b of 3, if you recall, is technically b, so that's 2b. So now we have 3a plus 2b. Our expression is in terms of a and b. Let's take a look at example 4. Write each expression as a sum or difference of logarithms. Express all powers as factors. All right, same idea here. You've got two values, m and n. So what we can do is break it up using our properties of logs. Log base 3 of x minus 1 plus log base 3 of x plus 2 all quantities squared. Remember, if something is taken to an exponent, you can bring that exponent in front as a coefficient of the log. So now what we have is log base 3 of x minus 1 plus 2 log base 3 of x plus 2. Okay, so now we have written it as a sum or difference of logs. There we go. Let's take a look now at example 5. Write a logarithmic expression as a single logarithm. All right, let's see, which one should we do here? I like to do the more complicated ones in these videos. Let's go ahead and take a look at, let's do C. So we have 3 terms here. Notice how we have a coefficient for the first one. In our first term, there's really nothing we can do with that, so we're just going to skip that for now. And then we know the coefficient can be brought up as an exponent. So I'm just going to rewrite this, ln of x minus 2 plus ln of x, well, this is to the half power here. And then minus, again, we have a coefficient that can be brought up. So we have ln of x plus 3 to the 5th power. And that's all of x plus 3, not just the 3, not just the x, it's the entire x plus 3. All right, combining a little bit more, I do see that we have natural log plus natural log minus natural log. So we know that when we're combining logs with the 4 basic operations, we can combine it actually as one whole natural log. So in this case, our entire natural log, remember that if you're adding them, they get multiplied. So what we have is x minus 2 times x to the half. What is x to the half? That's technically square root of x. And then whenever you subtract your natural logs, remember that's technically the same as dividing as one whole log. So divide by x plus 3 to the 5th power. And all of that is contained within parentheses. You do want to make sure you're very explicit in saying it's natural log of this entire thing here, like that. Okay? In fact, you want to make sure that you do that, let's say if you were plugging on the graphing calculator as well. Okay? The reason why is because if you just type it in on a graphing calculator and you say natural log of, and then it says parentheses, and then you just say x minus 2 and close it off, and say, oh, I'm going to multiply by root x, and then I'm going to push the division sign, and I'm going to divide by x plus 3 to the fifth, what your calculator is reading this as is just ln of x minus 2. Take that number and then multiply that by root x, and then take that number and divide it by x plus 3 to the fifth, when in fact you wanted the natural log of the entire set here. Okay, so just be aware of that. All right, let's do one more. Let's take a look at f, since that is the last one there. Again, we see a coefficient. What we can do is bring it up. So this is the same as ln of m to the half power. Oh, wait a minute. This is very similar to c. Oh, they're all kind of similar to each other. Oh, well, let's just keep going. And then we have minus. Again, I see an exponent there. Going to bring that up. So we have ln of n squared. And then we also have a 3 there. Bring that up. So we have ln p to the third power. Okay, so now, again, we have logs combined with the 4 basic operations, addition, subtraction there. So we're just going to go ahead and combine it all as one log. Notice how m to the half, that's the same thing as square root of m, is minus ln of n squared. So we're going to have to divide that by n squared. And then, you know what, let's just go step by step. So what we have here is now plus ln of p to the third. But because you are adding 2 logs together, now what we can do is combine those. So we have natural log of m. Since it's plus, we need to multiply by p to the third power. And all that is divided by n squared. Remember, this is all as one natural log. So ln is in parentheses there. All right, I think that will do it for today's notes.